Okay, here we go. This is notes number 20. And what we're doing today is kind of pulling together all the ideas that we've been accumulating for this unit into what I like to call the big problems. And when you do big problems for a few days, you don't do very many problems at a time. They have a lot of parts. Some of the parts are short, some of the parts take longer, but it's going to culminate in graphing a polynomial function. So first let's talk about the steps, and then let's do a few examples. Okay, so here are the things I'd like you to do when you solve a big problem. Number one, you're going to find the number of roots, also known as zeros, for the polynomial. This will be really easy because if it's cubic with an exponent of 3, then it has 3 roots. If it's quartic, it has 4. If it's quintic, it has 5. So it matches up with the highest exponent. So that part is really quick and simple. Then you're going to make the real, non-real table like we practiced yesterday in our notes, saying how many of the roots could be real and how many could be non-real and all the possibilities. You're going to make the general sketches like we did yesterday, and these general sketches show the end behavior based on the leading coefficient, and they show the number of roots possible. You're going to make the APRR list because that's going to help you narrow down what to try as you're looking for roots. Then you're going to find the roots, and that's where you're going to spend most of your time because as these problems get more difficult, it's going to take longer to find the roots. You're going to be doing a lot of synthetic division, and you're going to make that synthetic division chart that we saw yesterday. Finally, you'll put that information together and you'll graph the polynomial. Okay, so here's big problem number 1. So notice we have p of x. P of x is a quartic polynomial. The highest exponent is 4, so the number of roots is 4. Okay, bada boom, bada bing, that part is done. Real and non-real table. Remember that non-real roots always come in pairs. So there are 4 roots altogether, so it could be that 4 of them are real and 0 of them are non-real. It could be that 2 are real and 2 are non-real, or it could be that 0 are real and 4 are non-real. And I'm going to give you a little insider tip. Even though it's theoretically possible to have 4 non-real roots, I'm not going to give you any problems like that. We still put it in the chart or the table just to be thorough. Okay, now for the general sketches. So we have 3 possibilities from the 3 rows of the real and non-real table. So we're going to draw 3 sketches. Notice that the leading coefficient of the polynomial is 1, and it's a positive, so that means this one's going to open up. So opens up and has 4 x-intercepts for 4 real roots, or opens up and has 2 x-intercepts for 2 real roots, or opens up and has 0 x-intercepts for 0 real roots. Okay, now we're going to make the APRR list. So we start by listing all the potential numerators, which are the factors of 24. So that would be plus or minus 1, 2, 3, 4, 6, 8, 12, and 24. And then all the possible denominators, which would be factors of the leading coefficient, and that's 1, so just plus or minus 1. So then when we put that together, we get just plus or minus 1, 2, 3, 4, 6, 8, 12, and 24. Okay, so now it's time to make the chart for synthetic division so that we can start looking for the roots. So I'm going to make my 0 row in the middle, leaving space above and below. Making lines around it or using a highlighter or something so that it stands out. We want the 0 row to stand out. Here are the coefficients. Looks like we don't need any placeholders. We have all of the powers from 4, 3, 2, 1, and 0. And then the last number is going to be the remainder, so we'll put a line to make a remainder column. Okay, so now we start doing our synthetic division. So I'm going to start with 1, and then bring up the 1, multiply that, and add the next number. Multiply by the number in the box, 1 is the number in the box, and add the next number. Remember, you don't have to do this in your head. you can use a calculator as soon as you realize there's a chance that you might make a mistake doing it in your head. Negative 12 times the number in the box plus the next number. Negative 6 times the number in the box plus the next number. So we don't have a root yet, but we do know that for graphing, which is going to be the next step, we have the point to plot 118. Remember, the remainder is also the y-coordinate of the point. We also have the point to plot 024. So we keep going, bring up the 1 times the number in the box plus the next number in the 0 row, always going back to the 0 row. 0 times the number in the box plus the next number in the 0 row. Negative 11 times the number in the box plus the next number in the 0 row. Negative 16 times the number in the box plus the next number in the 0 row, and that will give us negative 8. Okay, we don't have a root, but we do have a good piece of information because it goes from a positive remainder to a negative remainder. There's a sign change from negative to positive, and that means there will be a 0 in between. We don't know for sure what kind of 0, and we don't have any fractions in our list, so that tells us it's not going to be a fraction, it's going to have to be an irrational number. So something like maybe square root 3 or something like that. So let's keep going. What I'm going to do is pause and fill in a few more rows. Okay, notice that I did the row for 3 and the row for 4. And the row for 4 shows a 0. So that means that 4 is a root. So we have one of our roots, but there are going to be 4 roots, so we need to keep searching for another one in the table before we can get it down to the final 2. I'm going to go in order. I'm not going to skip around. And for this problem, it makes sense to go in order because we do have 1, 2, 3, and 4 in the APRR list. But as you'll see in future problems, even if I didn't have one of those numbers, I would still go in order. And that's because I'm looking for things like sign changes. Sign changes are going to be really helpful to notice as the problems get more difficult. Remember, this is our first problem, so it's not difficult yet. So if you learn some habits while the problems are simple and you continue to apply those habits, it'll make doing the more difficult problems a lot easier for you. So let's do negative 1, bring down the 1, multiply by the number in the box, add the next number, multiply by the number in the box, add the next number, multiply by the number in the box, add the next number, multiply by the number in the box, add the next number, and then I'm going to go ahead and pause and do a couple more rows. Okay, I just did the negative 2 row, and actually I think I wrote that down wrong. I meant to write negative 2 times 12 is negative 24 plus 0. There's a 0 there, so we have another root. We have a root at negative 2. So we talked about this a little bit in the last lesson. I want to show you now how you can find the next couple of roots. So now that you have 2 roots and there are only 2 left, what you can do is take one of the roots and divide it into the other roots row, because the other roots row is showing you the remaining polynomial. So if you want, you can take 4 and divide it into the row from negative 2, or you can take negative 2 and divide it into the row from 4. It doesn't matter which. So let's say I decide to take 4 and divide it into the row from negative 2. So I'm just going to do that off to the side using normal synthetic division. I'm expecting to get a 0 because we knew that 4 was a root, so we knew it would go in evenly. But what we needed to know were these numbers, and that means 1x squared plus 0x minus 3. So what we're going to do with that is set it equal to 0 and solve for x. X squared equals 3, x equals plus or minus square root 3. Now remember earlier when we had the sign change, I said that means that there's going to be a root that falls between 1 and 2. Well, square root 3 is approximately 1.7, so it's the root that falls between 1 and 2. Okay, so all together then, we have our 4 roots. We have x equals 4, negative 2, and plus or minus square root 3. So we're ready to graph. So what you want to do is look at your table, your synthetic division chart, look at those remainders because those are the y-coordinates of the points, and figure out how high and how low you want to go. It looks like we need to go at least down to -30 and at least up to 24. So I'm thinking maybe I'll go by 3s on my y-axis. And it just depends on your graph paper and the amount of space you have. Your scale might be different from my scale. You just need to label it. And then I'm going to go by 1s on my x-axis. It's fine if the scale is different on each axis as long as you label it. Now we're going to plot all the points from the table, from the chart. So first of all, let's do the roots. We have a root at 4, that's an x-intercept, and at -2, and at square root 3, which is about 1.7, and negative square root 3, so -1.7. And then the other numbers we have from the chart are 3, -30, 2, -8, 1, 18, 0, 24, -1, 10. Okay, so now here's where you put to work your dot-to-dot skills from when you were young. Remember what it's going to look like because we made the general sketches over here. It's going to look like a W shape opening up. So we can just connect those dots. I don't know exactly how low to go or how high to go. We don't have a perfect graph, but we have as much detail as we're going to get this year. Next year in calculus, you'll learn how to find the points where it turns around, the maxima and minima, and then you can do an even better job of making that graph. So there's your first big problem. And we're going to work through 2 more big problems today. Now what I want you to be expecting is that as we go through this process today and tomorrow, these problems are going to get more difficult and some different kinds of things will occur. So they won't all be as predictable. They won't all be exactly like number 1. And I'm calling this one big problem number 3 because I decided that I wanted to give you big problem number 2 for homework. So I didn't want to rearrange the order of the numbers and confuse myself. So you can write down the polynomial and notice that the highest exponent is 4. It's quartic, so it has 4 roots. So every quartic polynomial is going to have the exact same real and non-real table. So this is going to look just like it did for number 1. Could be 4 and 0, could be 2 and 2, could be 0 and 4. And this one also has a positive leading coefficient. We have a positive 2. So these are going to open up. So these general sketches look just like they did for problem number 1. 4 x-intercepts, 2 x-intercepts, and no x-intercepts. And then for the APRR list, the numerators are going to be plus or minus factors of 9. So we just have plus or minus 1, 3, and 9. And the denominators are going to be plus or minus factors of 2. So we have plus or minus 1 and 2. So then we make all the combinations of those numerators and those denominators. And we have, let's put them all over 1 first, plus or minus 1, 3, and 9. Those are over 1. 1 over 1, 3 over 1, 9 over 1. And then 1 over 2, 3 over 2, and 9 over 2. Okay, so there are 12 numbers in that list. Those are the only things that could be rational roots. Any other roots would have to be irrational or non-real. So let's make the chart. We have 2, -5, -9, 15, and 9. And then I'm going to just start making some rows, so I'm going to pause while I do that. Okay, so at this point I have the rows for 1, 2, and 3, and I want to point out a couple of important things. So the obvious thing to point out is that 3 is a root because we got a 0. But the other thing I want to point out is that I made a row for 2. Even though 2 is not in my APRR list, and I know that 2 is not going to be a root, I made a row anyway for 2 important reasons. One reason is I'm going to want to have a lot of points to plot, and 2, -5 is a point I can plot. But the other even more important reason is that by going in order and not skipping anything, I was lucky enough to see a sign change, and that's an indication that there's going to be a root between 1 and 2. And you know what? That could be 3/2. I don't know yet, but it could be 3/2. That's in the APRR list. So at this point, what I'm going to do is try a few more rows. Okay, so notice that I did the row for -1 and -2, and even though I didn't get a 0 for either one, we do see a sign change. So we see the remainders going from positive to negative, and that indicates there's going to be another root in between. It might be rational, it might not. If it is rational, then it has to be -1/2. If it's not rational, it's irrational. And the way we find irrational roots is by using the quadratic formula, so we're not ready for that. We have another sign change here. So same idea, and if it is rational, it has to be -3/2. So we have one root for sure and 3 sign changes, which means we have located roughly all 4 of our roots. So there's no need to go through and do any more rows in the chart, except if we want to try one of our fractions. So I guess I'm going to go back and make some room down here, and let's start trying the fractions. So we can try 3/2, we can try -1/2, and we can try -3/2. Doesn't really matter what order you decide to do this in. So let's say I try 3/2. So 3/2 times 2 is 3, plus -5 is -2. 3/2 times -2 is -3, plus -9 is -12. 3/2 times -12 is -18, plus 15 is -3. Did I do that right? 18 plus 15 is -3. 3/2 times -3 is not an integer, so that's not going to be 0. Let's try -1/2. -1/2 times 2, and you can do this on your calculator. Why am I doing it in my head? I don't know. -1/2 times 2 is -1, plus -5 is -6. -1/2 times -6 is 3, plus -9 is -6. Again, -1/2 times -6 is 3, plus 15 is 18, and -1/2 times 18 is -9, plus 9 is 0. Okay, so there it is. So we have another one. And so at this point, we're going to do what we did in the last problem, which was once you have 2 roots and you only have 2 more to find, let's divide one of them into the other root's row. So let's take 3 and divide it into the row from -1/2. So we'll do that off to the side. Bring down the 2, multiply by 3, write it down and add, multiply by 3, write it down and add, multiply by 3, write it down and add. Okay, so we have 2x squared plus 0x minus 6 equals 0. So 2x squared equals 6, divide by 2, x squared equals 3. Oh, same thing as the last problem. That's probably a bad thing that I didn't plan that better. Plus or minus square root 3 again. So here we have our roots. X equals 3, -1/2, and plus or minus square root 3. And then to finish the problem, we're going to graph. So again, look at all your y values, figure out a scale. I think this time I'll just go by 2's on the y-axis. And we'll go by 1's again on the x-axis. Okay, let's plot the points. We have 3, 0, That's one of our roots. We have negative 1/2, 0. That's a root. We have square root 3 and negative square root 3. And then back to the table, we have the point 2, negative 5. We have the point 112. We have the point 0, 9. The point negative 1, negative 8. The point negative 2, 15. And that's all we have. Now, if you have some points that just don't seem to fit the pattern that you're expecting to see, that would be a red flag that there's a mistake somewhere. Remember, again, we have this quartic W shape that opens up. And there's our graph. Okay, what I'll do, we do need to go through one more example. And keep in mind that there could be different things happening in future problems, so don't assume that you have all the information you need for every problem. I'm just kind of giving it to you little by little. So there's another thing we haven't seen yet. It's called having a double root, and we need to encounter that here in a future problem. It might not be today. I can't remember if that's going to come up. But anyway, I'm going to end this video, and then I will start a new video where we do our third example for today, and then you'll have only 2 problems for homework.